Welcome to Retro Relix. This time we're going to explore the 1981 Osborne 1 portable personal computer. Let's see what we can find out about Adam Osborne's luggable computer. The massive, unmissable red double-density label on the box suggests this might have dual drives at 182 kilobyte storage per diskette. The entire computer was enclosed in a 1980s beige plastic case with a black plastic fascia at the front. Clips to retain the keyboard on the side and power input at the rear with a handle allowed the computer to be manually transported, and as a result is considered to be the first affordable portable computer to achieve widespread use. So let's open the front fascia and have a look inside of this Osborne 1 to see what technical marvels this luggable computer has in store for us. Warning, no user serviceable parts. That's that then. The frame is 5mm thick and houses all of the computer's key components. This includes the screen, disk drives, power and the wiring loom. The underside has two riveted metal plates which houses the motherboard. There's also a rear handle and metal posts to secure the power supply, which appears to have suffered a component issue. The centralized screen is a 5-inch cathode ray tube which has an external screen filter installed, which indicates this Osborne 1 probably has a white phosphor display, as these were more prone to glare than the green ones. The CRT is connected to the computer via an edge connector, and the unit is surrounded by a low-level emission shield. This CRT was manufactured by Motorola and consumes 0.8 amperes at 12 volts direct current. There are two 5¼ floppy disk drives. The disk drive was manufactured by Siemens and was operated by the usual read-write sensor, belt drive, microswitch and stepper motor. Interestingly, this drive A was replaced on the 28th of November 1983. Although labelled as a 115 voltage alternative current power input, this unit was capable of receiving up to 240 volts to cover the European market. Power input was up to a 6 amp 250 voltage AC power line module. On the back we can see a meze of wiring with several neutral wires and the back of the on-off rocker switch. The power supply is mounted at the rear and underside of the frame. It's an Aztec Components power supply made in Hong Kong and installed during week 49 of 1982. We can see the output voltages, and although this power supply has 3 outputs, this unit only requires 2 of these. In addition to the standard live, neutral and earth connections, as we saw from the power input unit, there are 2 additional neutral connections. However, we previously observed the remnants of a power supply issue, so we're going to replace this power supply with something a little more modern. The Osborne 1's motherboard is secured by 4 screws to the riveted metal bracket at the base of the frame, covering the entire width of the unit, which it needs given there's just over 100 chips on the main board. Although the board is embossed with copyright 1981, Osborne Computer Corporation, Revision F, further identification identifies this board as being manually marked Revision J. Reviewing the technical manual, we can see Revision J's release date was approved on the 3rd of January 1982. Switching back the other way, we can see marked across the board is 1 to 27 and downwards A to E. The central processor is the NEC C780C, which is equivalent to the Zilog Z80A. So remember the double density box label. Well, checking on the board, fortunately this is installed, so we'll look forward to checking that later. And as for that torn yellow column upgrade label we saw on the box earlier, well, it should be here and looks like this. So we don't have this at the moment, but something we will install in the future. Looking through the Osborne One's available interfaces from left to right, we have a DE9 pin modem port with a selectable baud rate, a DB25 pin to transfer data between other computers or peripherals, a 26-pin IEEE 488 edge connector parallel interface to transfer data faster between other computers or peripherals, a 20-pin interface which uses a 9x9 key switch matrix to monitor key presses from the keyboard, screen display brightness and contrast, a 20-pin edge connector used to direct video signals either to the internal screen display using an adapter plug or a special adapter to replicate the video signal, such as this XMON example, but more on that later. A reset switch and a DE9 pin battery connection. The original idea was to store batteries in the large space available within the keyboard. However, this was ceased due to weight, maintenance and safety concerns. That said, third-party solutions were available which provided 3 hours of mobile operation and a unique audio-visual alarm. On the underside of the motherboard, it's clean and tidy with no bodge wires or broken traces. The Osborne One has a detachable full-stroke keyboard with separate numeric keypad. There are retaining clips on the side to secure it onto the case using these clasps, which are riveted onto the case. The keyboard has one connection cable, which is the 20-pin interface we viewed previously, and the outside of the keyboard originally supported rubber strips when stored upright. Inside the case, there are white retaining blocks to level the keyboard. The keyboard was fabricated by Oak Switch Systems in what appears to be early June 1982 and has 2 protruding ribbons which feed the 20-pin matrix connector. Looking further, the keyboard supports individually spring-assisted mechanical keys which still remain aesthetically pleasing after all this time. The case is one large part, featuring rubber strips when in use, the Osborne logo on the sides with the keyboard clasps, leveling blocks for the fascia, a rectangular hole for the handle and a power input plastic cover secured by 3 Velcro strips. On the inside of the plastic cover is a riveted retaining arm with holes in either side. However, I'm not sure what this is for. At the base of the power input entrance is a label which warns of unacceptable radio and TV reception interference, maybe one for Ofcom. The front fascia is made of black plastic with holes for retaining screws, interfaces and airflow control, which are fastened on the rear of the plate, as are the storage compartments. So now we've seen the Osborne 1's components, let's restore it and get it working. We know the Osborne 1 needs +5 and +12 volts to operate as confirmed on the power supply. So with this replacement AC to DC power supply, we can configure the wiring and mount into the 4 posts we identified earlier. However, as this new power supply is smaller, I've 3D printed a mounting frame, fitted and wired up the replacement power supply and mounted it safely and securely into the Osborne 1. Having cleaned the disk drive read-write head with rubbing alcohol, greased the stepper motor spindle and supports, removed and cleaned the drive belt, it was time to check the rotational speed of the motor. This is achieved via the trim pot at R23 on the disk drive's circuit board. So we're aiming to calibrate the rotational speed using a strobe light set to either 50 or 60 Hz, dependent upon which row you use. Please be aware of strobe light effects for the next few seconds. Having reconfigured the trim pot, I corrected the rotational speed, which was slightly out. Due to their age, retro disk drives can now be somewhat unreliable, so I wanted to install something a little more dependable. In this case, a Gotek floppy disk drive emulator, which uses a standard USB drive to store and transfer disk image files. To achieve this, you simply connect all of the pins from the Gotek to the dedicated interface. Then, to build the Gotek housing, download a previously created object, load it into your 3D printed software for positioning, and 3D print it. After around 8 hours, you should have something like this, which I've painted to match the Osborne 1's fascia, secured in the Gotek and installed onto the Osborne 1's frame. Before we reassemble the Osborne 1, let's do the smoke test to see if any of the components are working. That beep is a good sign. Oh, and yes, I can see the screen with Osborne 1 revision 1.44 copyright 1983 OCC. Although it asks to insert disk in drive A, which in this case is the right hand drive, let's press the shift and double quotes key above the return key. This loads from drive B, and we can see the drive light is on and it's performing a seek. Yes, it's loaded SuperCalc from the double density disk, so we know that double density daughter board works okay. Let's try loading something from the Gotek on drive A. The green light is on and the Gotek display is counting up. Great, everything works. Time to reassemble. To future-proof the Osborne 1's motherboard, I've installed heat sinks with thermal paste to absorb excess heat. secured it on with those metal brackets and glued the external filter to what we now know was the white phosphor display. Now, using the wiring guide, let's put these back together, starting with the power input. So let's connect the power to the motherboard and all earthing points. Now we've installed heat sinks and a more efficient power supply, I don't think we need these thermal cutoffs anymore. Interestingly, these open the circuit at 65 degrees Celsius and close them again at 55. No doubt to stop the Osborne One from overheating. As our new power supply has a 12 volt direct current out for a fan, to be on the safe side, I've installed this brushless cooling fan to push out all internal airflow. Our quick test shows this Osborne One is now working with all of our modifications. Earlier we spoke of the 20-pin edge connector to provide the video, which appears to be a TTL transistor logic signal. The Osborne employs what's referenced in the user reference guide as a rectangular shaped plug which redirects the video signal to the internal CRT screen display. Plugging in the XMON special adapter, it displays video to the internal screen and to an external video. However, as we can see, the quality is terrible. Having opened up the XMON special adapter, I found some loose contacts which were short in the adapter, so after a quick clean-up, it worked perfectly. Checking the internal and external displays side by side, they are perfectly synced with a great quality signal, although the external Sony monitor did lack the luminosity of the Osborne One's tiny 5-inch CRT. I also tried to direct capture the video signal from the Osborne One to a PC, but unfortunately the signal didn't synchronize correctly. The Osborne One was packaged with a whole host of software, which included SuperCalc. So we've got our keyboard template loading SuperCalc, and within the spreadsheet we're going to do 10 multiplied by 10, which, all being well, is 100. Okay, moving on to WordStar, a document type editing program. So, hello, this is 2023. Moving on to basic. 10. Print. The Osborne is great! Exclamation mark. Okay, Planet 4. Infocom Interactive, a science fiction story. The pod bulkhead is closed. Open bulkhead. Why open the door to the emergency escape pod if there's no emergency? Right, okay, that's enough of that. Let's move on to something else. What have we got here? Let's do a directory listing. Oh, Zork. Zork 1. I've heard of that. Let's type that in. The Great Underground Empire. Copyright 1981, 82, 83. Zork is a registered trademark of Infocom. Okay, you're standing in an open field, and there's a small mailbox here. Open mailbox. Oh, it's a leaflet. Read leaflet. Welcome to Zork. Well, that's great, and probably for another time. So, there you have it, the world's first commercially available portable personal computer, all fixed up and ready for a few more years of retro CP/M goodness.